So before I get into the practical component of actually sampling for our benthics, I kind of want to go over the procedure and a bit of the gear we would use. So number one, waders definitely help a lot. But number two, here we have our D-net. So this is used for shallow body lakes, or specifically streams really. So our D-net. This is a 500 micron mesh net, which is ideal. You can go as low as 400, but with the 500, we're going to capture those really small macroinvertebrates that might get through the gaps in our 400 micron mesh. So with this, we're able to get a more accurate representation of what's actually in our water body. So for the actual procedure, what we're going to do here is the kick and sweep method. So for that, we're going to want to first find, ideally, a riffle pool sequence. If you don't know what a riffle pool sequence is, there'd be a shallow area that might be kind of rocky, where there's an increased flow. And then we get a deep pool, and then another shallow rocky area. So it's a riffle, pool, riffle. And then we are going to do the kick and sweep method, which is just a diagonal from either side of our stream to the rest. It would be 3 lines. And ideally the whole process takes about 10 minutes, but it can vary. If you have a really small stream, it might take much less time than that, but ideally you don't want to go over 10 minutes. So if you have a more deep stream, you can use other sampling equipment such as an Ekman dredger, for example, something that is not weightable. All right, so we're off. So unfortunately, I do not have a riffle pool sequence to show you the proper procedure of sampling for benthics, but I do have this little stream here, and I'm just going to use this to show you the procedure. So it is very important that we start downstream and work our way upstream, so we're not disturbing things upstream before we even get to them. So we want to have the direction of flow at our backs. And what we will do is we want to do a twisting motion as we move backwards. That way we're picking up anything that might be stuck in the sediment, and the flow will push it into our nets. So I'll begin here. That is the general procedure for how we got. So unfortunately this is a very shallow stream. It was hard for me to really get anything, but I think you understand the process from that, and now we'll go take a look to see if we got anything. Come on. So we'll see what we got from our very short kick and sweep. As I said, they're supposed to be about 10 minutes, but for the purpose of the demonstration here, that'll do. So what we have here is a couple mesh filters. This one's a little more coarse. I'm going to use it at the top to get out any big pieces of material, rocks, leaves, sticks, or it makes it easy to find any really big benthics we might find. And at the bottom, it's very important that we have the same mesh that we have for our net. So this is again a 500 micron sieve. So now what we're going to do is we're going to take, it's easier to do this section at a time. So we're going to take a chunk of our sample here. Make sure there's nothing on my hands that might get missed. No. And we're going to take a pair of tweezers, and we want to slowly examine every single leaf that's in here. We want to be as thorough as possible, so that way we can get as accurate of a representation of what we've actually collected. Nothing on this one. And we're going to keep going through our sample until we've taken out all of the big debris, and then we're left with, oh, look at that. We got a couple scud. Let me get my bucket here. And here we have a scud, or as some people call them, a side swimmer. You want to be very careful picking them up with the tweezers as not to squish them or break them. And there is our little scud. So now that we've sieved through our entire sample, we'll see what we have here. This sample is just from our first, what would normally be our first riffle. So each riffle pool, and riffle has its own separate sample. And ideally, we want to get 100 specimens from each sample for a total of 300 for the Hilsenhoff index that I'll talk more about at the end. So we definitely don't have 100 here, but I'll show you some of the things that we got. So we have a couple tools that we use. You can use tweezers to grab them, which is a little bit harder in the water, or we can use one of these syringes, which is really only effective for picking up very small specimens, but much easier than the tweezers, such as this sow bug here. I managed to get him right in there. I can squeeze him out into my hand, and there we have one sow bug, which, if you remember, is a poor benthic to find. We also have some side swimmers. We have this guy, which is a really cool find. Oh, now he's went back into his shell, but in here is a caddisfly. Let's see if we can get him to come out again. Oh, we just poked his head out. So caddisflies will find hollow sticks, or seems to be a tube from some sort of piece of grass, and they'll use it as a home. They'll actually build up rocks and other debris around it to make a hard shell, and that's what they live in. And like a snail, as they grow, they'll shed the shell and make a new one. We also have a crane fly larva, which is identified by its ribs along its body. You can see them maybe a little better as they move. All right, so now that we've sieved through our entire sample, so say we had more than 100 of them, we need to pick out 100, but we can't just go in and pick out the ones that we want, because as humans, we're gonna pick out the bigger ones, which is gonna make our sample biased. So we have a method here to make this as unbiased of a process as possible. So what we have here is just a tray with a grid in it, and if you can see on the side, there's numbers, it's numbered. So we're going to dump our entire sample into this tray. So what I have my sample in here now is just a tray with a grid, and on the side of my tray I have numbers. So this is used to avoid bias. So we don't want to just pick out any one of our samples, as I said, because we're naturally just going to go for the larger samples, which is going to bias the results and therefore skew them. So what I have here is with these numbers, I can use a random number generator to find out which grid I want, or which cubicle, and I can then pick out whatever the number generator tells me, and I'll get everything in that little zone, and that way I can avoid bias. If you don't, this is kind of a more simple method. There's also something called a marchant box, which will actually have, it's like these little grids, but it's 3D, and then there's a lid that goes on top of it. You flip it upside down, it seals. You swirl it around gently and quickly flip it back over, and then you can pick every other little cubicle, again, to avoid bias. So once we have our 100 specimen picked out from our grid, we can refer to the Hilsenhoff index. That has a number associated with each family of bugs that we're going to find, because here we're identifying them down to a 27 taxa at the family level. To go to a species level is far more intricate. Say we have 10 stoneflies. The number associated with a stonefly is 1. The lower the number, the better. Then say we have 5 mayflies, so we have a total of only 15 species for this example. The number associated with a mayfly is 5. So we're going to go with our 10 stoneflies, it'll be 10 times 1 plus their 5 mayflies, 5 times 5, divided by 15. It's divided by the total number of species that you have. And we're going to do that for our riffle, our pool, and our riffle, and we're going to average those numbers, those 3 numbers that we'll get at the end, and it will give us one number that will be the score, for the benthic score for the water body that we have sampled.